So looking at this last question, this is a bit of a problem because we have product rule and quotient rule in here at the same time. So how do we deal with that? Well, how do we deal with that product and quotient rule at the same time? What we can do is we can either apply the quotient rule on the product rule. Okay, so we can do the product rule and then apply the quotient rule, or we can do a product here, or sorry, quotient here, and then apply product, or we can do a quotient. In fact, it really doesn't matter because the multiplication or division doesn't have any priority. So how I'm going to set this up is I'm going to set this up as a product. So I have my e of x and I have my sine x. So that's my product. And then that's going to be represented by that numerator will be one piece and the denominator here is going to be separate. So I'm going to do the product first, and then I'm going to apply the quotient rule on top of that. So what does that look like? Okay, so my derivative function is going to look like this. Okay, so I'm going to differentiate. I'm going to differentiate here, and maybe I'm going to put it in a black box here. This is going to represent the derivative of the numerator. Okay, and then I'm going to multiply it by the denominator, which I'll do like that. Plus, or minus, sorry. I'm going to take my numerator, and then I'm going to multiply it by the derivative of the denominator, like that. And then all over top of that will be the denominator squared. Okay, so here you can see there is my quotient rule. Okay, the numerator is in black, the denominator is in blue. Now, inside of this quotient rule, I'm going to apply the product rule. So there's going to be the derivative of the first part, which there's my derivative, times the second part, plus, it's going to be my first part times the derivative of the second part. So inside, where I'm going to actually differentiate the numerator, so that's the derivative of the numerator, inside here you can see there's my product. Okay, there's my product rule is going to be in there. Okay, so I'm just going to write these pieces in. Okay, so it's going to look like this. It's going to be the derivative of the first number times the second number, or the second function, undifferentiated, plus is going to be the first function undifferentiated times the derivative of the second function. Okay, so this is my cos x differentiated. I'm just going to erase that because that's my derivative already done. Okay, so then there's the derivative of the numerator. That represents the derivative of the numerator. And so then I'm going to multiply this by, well, that's going to be, nothing's going to happen to the log there. I'm going to have this function here. It's going to be, nothing's going to happen to my original function because it's not differentiated. So I'm going to have e to the x times sine x. Okay, nothing's going on there. The derivative of the denominator is going to be 1 over x. And then the denominator, well, we don't differentiate it. We're just going to square whatever's in the denominator. So it's going to be denominator squared. Okay, I'll just take away that and it looks a little bit nicer like that. Okay, so there it is. So on the outside skeleton, you can see that the quotient rule, where we differentiate the numerator, within that, just this piece here, this is the only place that the product rules is used. I've embedded the product rule inside that part. Okay, so there it is. That's the whole thing. I'm done. I've done the derivative. Now, I can simplify this. In fact, I should simplify this. Okay, and wherever I can. There's really not much I can simplify other than it looks to be a common factor of e to the x. Okay. Now, for the most part, I'm more interested in this because now we can use this to find slope Okay, the simplification part kind of is secondary, but as you go into university calculus, that actually becomes much more important. So make sure that you are able to do these simplifications. So log x sine x plus cos x minus, that's going to be sine x over x, and then all over log x squared. Okay, so there it is.